So in this video, we're going to cover adding and subtracting complex numbers. So this should be a pretty straightforward process, I think, for most people. So we have a sum of two complex numbers, and we recognize we're going to get complex numbers because we're taking the square root of a negative. So first thing I want to do probably is rewrite the problem completely. Plus, and then I have 7 plus the square root of -3, and I want to recognize with this addition sign in front of the parentheses that it isn't going to change anything. If we distribute an addition into a parentheses, everything inside the parentheses will remain the same. So in this case, both sets of parentheses can be dropped without changing the problem. So I'm going to drop the parentheses. I'm going to get 12 minus, and then here I have the square root of -4, and I want to recognize from previous video that if we have the square root of the opposite of a positive number, that we can just rewrite this as the square root of that positive number times I. So I'm going to rewrite this as the square root of 4 times I, where I is not underneath the radical sign, plus 7, plus this can be rewritten, the square root of -3 can be rewritten as the square root of +3 times I, where I is not underneath the radical sign. And once I get everything broken out of the parentheses, when you're adding or subtracting complex numbers, it's simply a matter of taking the real number parts, the parts that don't have the i's, and grouping them. So I have 12 plus 7, and then grouping the parts that do have complex components. So both of these have I, so I have a minus the square root of 4 times I plus the square root of 3 times I. And I can do 12 plus 7. I know how to do that. That's 19. And then I have minus the square root of 4. I can actually simplify this because the square root of 4 is 2. So I get minus 2 times I plus the square root of 3 times I. And usually when you're doing these, you want to do standard form. So standard form is going to be to get it in the form A plus some real number times I. So right now I have an I in both pieces here. So what I'm going to do is use the distributive property, and I'm going to factor an I out. So plus, and I'm going to factor out an I, and what's going to, if I pull an I out, I'm going to be left with the -2. I have the -2 here. I'm be left with the square root of 3. And when I look at these two, I can't really simplify those, so this is where I would stop right here. And in terms of the standard form, this is the form A plus B times I that I have up here, where A is 19. I don't need to write this. I just want to emphasize the pieces. A plus BI. A is 19, and B is actually this sum right here, -2 plus the square root of 3, which is just some real number. Here it's a difference of two complex numbers. I've got a subtraction outside the parentheses. I know I'm going to have complex numbers because I have the square roots of negatives going on. So my first step is going to be to go ahead and rewrite the problem. Square root of 3 plus the square root of -2 minus the square root of 12 plus the square root of -8. So first step is going to be to distribute the minus sign into the parentheses and rewrite these complex numbers in terms of I. So I have the square root of 3 plus the square root of 2 times I, where I isn't under the radical sign. Distribute the minus, so I'm going to get minus the square root of 12 minus and positive will give me minus, and I have the square root of 8 times I. So grouping the real number part, that'll be square root of 3 minus the square root of 12. And then grouping the complex parts, I have plus the square root of 2 times I minus the square root of 8 times I. And here I need to factor an I out, and I also need to begin to look at what I have here and ask the question, are these radicals in simplified radical form, and they are not, because 12 can be rewritten as 4 times 3, and 4 is a perfect square, plus square root of 2 minus, I have the square root of 8 sitting here, factor that I out, continue to simplify, I have square root of 3 minus the square root of 4 is 2, the square root of 3 doesn't simplify, plus I have square root of 2 minus, and I want to recognize that 8 can be simplified. It's not in simplified radical form because 8 can be rewritten as 4 times 2, and this is times I. Here I have 1 square root of 3 minus 2 square roots of 3, and 1 minus 2 is going to be a negative 1, so I get 1 root of 3 minus 2 roots of 3 is going to be negative square root of 3, simplifying those two terms. Plus, I have the square root of 2 minus the square root of 4 is 2. The square root of the 2 doesn't simplify any further, and I get I. And I can take this one more step. I bring down my negative square root of 3 plus, and this should compact. I have 1 square root of 2 minus 2 square roots of 2. 1 minus 2 is negative 1, or just negative square root of 2 times I.